Has anyone ever told you that a dead AA battery can be turned into a DIY soldering iron? It sounds a little unbelievable, right? I thought the same at first. But it actually works, and it's more reliable than you'd expect. Let me walk you through exactly how I did it. With this dead AA battery, I'm going to reuse the outer casing as the handle for a DIY soldering iron. The reason is simple. The metal shell is sturdy, easy to grip, and already shaped like a compact tool body, so it gives me a solid structure without having to build a handle from scratch. As for the inner core rod, I'll reshape it into a homemade soldering tip. This part is made from conductive metal, which can transfer heat efficiently to a small point, making it suitable for melting solder. By separating and repurposing these two parts, I can take advantage of the battery's existing materials instead of letting them go to waste, turning something unusable into a functional tool. Next, I'll pick one of these safety pins and use it as the connector between the heating head and the handle of the soldering iron. I chose a safety pin because it's made from spring steel, which is strong enough to hold everything in place and still conducts well for this setup. Its shape also makes it easy to hook and secure both parts tightly without much extra work. On top of that, it has just enough flexibility to keep the connection from coming loose while you're using it, which makes the whole build simpler and more reliable. Here we have a bolt and a nut. Simple parts, but they play an important role in building the heating head of this DIY soldering iron. Even though they're small, they're incredibly common and easy to find. That's exactly why I'm using them here. They help hold everything together securely while keeping the design practical and easy to replicate. Baking soda plays an important role in securing the safety pin to the handle when combined with super glue. When these two materials are used together, they create a fast-setting, hardened bond that helps lock the parts firmly in place. It's a simple trick, but very effective, especially when you need a quick and solid connection without complicated tools. With this 2x4 terminal block, I'll take it apart and remove one of the internal metal connectors to use as a linking piece. This metal part will act as a bridge between the threaded body of the bolt and the homemade soldering tip. The reason for doing this is that it already has the right shape and conductive properties, making the connection more stable, aligned, and easier to assemble without needing to machine a custom part. The type of wire I'm using to connect the key parts together is insulated on the outside, with a core made up of many small copper strands tightly twisted together. This design makes the wire flexible and easy to work with, while still maintaining good conductivity. It also helps create a more secure connection, since the stranded core can grip and adapt better when attached to different components. To keep the wire from getting in the way while I'm working, I'll use electrical tape to secure part of it along the handle. This helps keep everything neat and easier to manage during use. At the same time, it adds an extra layer of insulation, reducing the risk of electric shock if my hand comes into direct contact with the handle. With the remaining end of this wire, I'll attach an alligator clip. This makes it much easier to connect and disconnect during use, especially when testing or adjusting the setup. It also provides a firm grip on contact points, helping keep the connection stable without needing to hold it by hand. I'll also make an additional tool to connect to the negative terminal of the power source. It's quite simple in structure, just a length of wire with an alligator clip attached to each end. This setup makes it easy to link different parts of the circuit quickly, while keeping the connection secure and flexible during use. It makes a lot of sense to use a small battery as the power source for this DIY soldering iron. A compact battery like this can provide a steady current, which is important for maintaining consistent heat at the tip. It's also portable and easy to work with, making the whole setup more practical and convenient to use. We can clearly see an electric arc forming, which is a good sign that the setup is working. But to really understand how effective it is, we need to test it in practice. Let's use it to join some small metal pieces together and see whether the bond holds firmly without damaging the parts. So now, take a close look at the hands-on demonstration. There's a very common reason why a light bulb that was working fine suddenly goes out, and it usually comes down to a failed LED chip inside. These bulbs are made up of multiple small LED chips connected in series, so when just one chip burns out or loses connection, it interrupts the entire circuit, stopping the current from flowing. While we're in the testing phase, I'll show you a simple way to fix it. By applying solder to bridge across the faulty LED chip, we can restore the electrical path, allowing current to flow again and bringing the bulb back to life. We'll start right away with the first step, which is opening up the LED bulb to inspect what's inside. The goal here is to locate exactly which LED chip has failed so we can deal with it properly. Once we identify the damaged spot, the repair process becomes much more straightforward. And just like that, from a dead battery and a handful of simple parts, we've managed to build something that actually works. It's not perfect and it's definitely not the prettiest tool out there, but it gets the job done, and sometimes that's more than enough. What matters here isn't just the result but the idea behind it, looking at everyday objects a little differently and seeing the potential they still hold. Instead of throwing things away, we can take a moment to rethink, reuse, and turn them into something useful again. If you've made it this far, I'd say you've got the patience to try it yourself. Take your time, be careful, and enjoy the process. Thanks for sticking around to the very end, and I'll see you in the next one.